Welcome, calculus class. We are going to talk today about a new section, section 5.4. And the title of this is actually pretty intense. It is the fundamental theorem of calculus. Okay. There are two parts to the fundamental theorem of calculus. And technically today, we're going to spend 2 days on this. When I am back next time, we will discuss the other part of the fundamental theorem of calculus. But for today, we're actually going to focus on part 2. So if we write FTC, that stands for Fundamental Theorem of Calculus, Part 2. And we actually have already learned that. The Part 2 of the Fundamental Theorem of Calculus is what we learned yesterday in class about how to evaluate an definite integral from a to b of little f of x dx. So just a little reminder on this. This is actually equal to capital F of A minus capital F of B, where capital F of x can be any antiderivative of little f of x. Okay, and the key word there being any antiderivative, we can think of it as the antiderivative where your plus c is just 0, and that makes things pretty easy to think about. All right. So let's just review an example, and then we're actually going to get into our calculator and understand how to do this using our technology to check our answers. So let's look at an example here where our definite integral goes from -2 to 2. Notice how my notation on this is going to be. It's going to be x cubed minus 4x dx. Now this dx is very important. Remember, that just tells us what our variable of integration is going to be. Sometimes we actually end up with different variables in here. So we can actually apply a couple different properties to this integral that might make it a little bit simpler. We could say that this is just two separate integrals. So if we, almost think about it as distribution using our sum and difference property, now we don't need the parentheses because everything in here is multiplication. Does that make sense? So it's important with our differential here, dx, that we write that in both spots. Okay. Now, we certainly wouldn't need to do that. We could just find the antiderivative of x cubed minus 4x. And I'll do that in a second below. But working the problem this way, we end up antidifferentiating x cubed. You'd get x to the 4th because you have to bump your power. And then you need to decide what coefficient would give you just 1x cubed when you found the derivative of this part. So that would be 1/4. And then we are evaluating that part at 2 and -2. Subtracting, bump the power there, x squared. What would have to go in front? Well, the 2. 2 times 2 would give you 4x when you found the derivative, and That's what we need. We're also evaluating that piece. Okay? So, what this means is we go ahead and we go 2 to the 4th divided by 4 minus negative 2 to the 4th divided by 4 minus 2, and instead of x we have 2 squared minus 2 negative 2 squared. So this is one quantity that we need to simplify first. 2 to the 4th is just 16. 16 divided by 4 is 4. Negative 2 to the 4th is 16. 16 divided by 4 is 4. So we end up with 4 minus 4 here, minus this quantity, which is 2 times 2 squared. So 2 times 4 is 8, minus 2 times 4, which is 8. We end up with 0 minus 0, which, of course, is just 0. All right? This way might make more sense for you to apply the integral and do it both, or do 2 separate integrals. Some students, that's just a easier way to see it. Over here, we can just go straight down and find the antiderivative of this integrand all at once. So by doing that, I'm just going to get x to the 4th over 4 minus 2x squared. And this whole piece can be evaluated at 2 and negative 2. So this actually might save a little bit of time for you to do it this way. So you're going to end up getting, when you substitute 2 in for x, you get 16 divided by 4. So that's going to be 4 minus 2 times 4 is 8. So you're substituting your 2 in for x, you're going to get that. Now we subtract this term with negative 2 substituted in. So again, negative 2 to the 4th divided by 4 is 4. And then negative 2 times negative 2 squared, it's negative 2 times 4, that's minus 8. So we end up getting negative 4 minus negative 4, which is just 0, right? So either way, we get a net change of 0 when we evaluate the integral. Now let's look at why that would be using our calculator. So once we get our calculators ready, if you're using a Texas Instruments calculator, your process will be pretty much exactly how we do this. Or it's very similar to things we've done, and same with your Casio calculators. Our process to actually evaluate this definite integral is very similar on a Casio as well. So what we want to do first is we want to graph our integrand, which again, if we look back, that was the that was this function in here, that little f of x. Okay, so that's going to be x cubed minus 4x, and we want to graph that. And we want to make sure that our window shows the limits of integration, which are negative 2 to 2. So make sure that your window then shows that. Negative 5 to 5 definitely would show that as far as your x's. And your y's, if you want to get a good picture, negative 5 to 5 for this function will give us a really good picture of what's happening on our graph. So once we get our y equals in and we get our window set, we can go ahead and graph it and get a good look at it. Now, we talked in class about how area under the curve that is above the x-axis is going to give us like a positive value, right? So all this area, this is negative 2. So from negative 2 to 0, we're getting positive values here, right? for this area. Now, once we hit 0 and we go to positive 2, all this is area that is under the curve. And so this is actually going to give us a negative. And when you look at this portion and that portion, they appear to be equal, which might be why you end up with 0 minus 0. And does that make sense? And so that's why our net change for the integral, the positive area plus the negative area, is going to be 0. So how do we do this on our calculator? Well, we simply go to our calculate menu, and if you have some calculators actually give you this right here. Some of our calculators might say like FN int. I believe in our textbook on the problems we're going to do, it actually says like N, it's capital N, capital I, capital N, capital T, which just means numerically integrate with your calculator, okay? Our textbook's a little bit old. Anyway, once you hit that, your lower limit of integration is what it's asking for right here. What is our lower limit? -2. Our upper limit of integration? 2. And now this is probably one of the best parts of the class. Once you hit enter here, now we get to see where that shades in. All right, and now we can see, look, we were correct when we did our calculus work. -2 to 2, the integral from -2 to 2 actually is a 0 net change in terms of evaluating this integral. We'll get much deeper into the applications of all this, but first of all, we just need to understand the process of calculating these definite integrals. Here's an example of how you can do that. However you would like to do it, whether it's the way on the right or the way on the left. It doesn't matter. You just need to be able to do these and show this work. Okay, your assignment for today will be posted on the board. It's very similar to the assignment that you had or you received last time we were all in class. Or actually, I can just write it down right here because some of you will not be in class on Friday. So it's going to be page 303, and the numbers are going to be 27 through 39 odd. Okay, now this is going to be due Wednesday when we get back. Okay, so this will be due along with your 5.3 assignment. What these problems are simply evaluating definite integrals and then using your calculator to verify that your answer is correct. And you have the back of the book to verify that you're correct. But you need to understand how to do this using our technology. So I would hope that you would take the time and use your calculator to check your answers. Make sure you show all your work on these problems, and we shall see you on Wednesday. Email me with any questions. I'll have my email with me at all times while I'm in Salina. Thanks. Have a good day. Bye.